Hello everyone, welcome to my channel Physics Tricks. So let's start with Kinematics DPP, and in this we have first question. Let V bar and A bar denote the velocity and acceleration respectively of a body. Select the wrong statements. Okay, so we have to select over here wrong statements. A bar can be non-zero when V bar is equal to 0 indicates acceleration can be non-zero when velocity is 0. Yes, possible. Where it is possible, if you throw the ball with initial velocity, it will go to the topmost point, and at the topmost point its velocity will become 0. And what about the acceleration? Acceleration will still be minus g meter per second square. Indicates yes, possible. A bar can be non-zero, but V bar might be 0. Possible. A bar must be 0 when V bar is equal to 0. See, this is not possible because just now we have proved that A bar might be non-zero when V bar is equal to 0. So A is the correct statement, B is the wrong statement. A bar may be 0 when V bar is equal to 0. A bar may be 0 when V bar is equal to 0. So over here possible. How? So see, if you just go in the straight line with some velocity 10 meter per second, and if you stop supposed to be over here, rest. So what is the velocity? 0. What is the acceleration? 0. So yes, it is possible. The direction of A bar must have some correlation with the direction of V bar. Direction of A bar must have some correlation with the direction of V bar. Yes, might be there. Why? Because acceleration will always be in the direction of change in velocity is a direction, right? So acceleration will be in the direction of change in velocity. So ACD will be the correct statement. So what is the wrong statement over here? It is B. A bar must be 0 when V bar is equal to 0. So wrong statement is B. Correct statement ACD we have. Okay. So next question. Consider the motion of the tip of a minute hand of a clock in 1 hour. In 1 hour, what will happen to the minute hand? Okay, so this is the minute hand. What will happen to the minute hand in 1 hour? So in 15 minutes, it will be somewhere here. That minute hand in 30 minutes, it will be somewhere here. In 45 minutes, it will be somewhere here. In 1 hour, the tip will be at the same position. In 1 hour, the tip will be at the same position, we can say, isn't it? Right now. So indicates what? Indicates the displacement of this tip in 1 hour. Displacement of the tip in 1 hour is 0, right? Is 0. Displacement will be 0. Then what about the distance? Distance is non-zero. Why? Distance is non-zero, and if you want the value, you can write it is 2 pi r. If displacement is 0, what about the average velocity? Average velocity also becomes 0. What about the average speed? It is not 0, right? It has a value, right? It has a value, that is distance 2 pi r by time capital T. So I hope this is clear. So the displacement is 0, correct. Distance covered is 0, wrong. Average speed is 0, wrong. Average velocity is 0, correct. So A and D are the correct options over here. A and D are the correct options over here. Now the next one. Two trains each 100 meter long moving in opposite direction cross each other in 10 seconds. Okay. So two trains are there, 100 meter long, moving in opposite direction, each 100 meter given. Okay, cross each other in 8 seconds. If one is moving twice as fast as the other, if one is moving with x, other is moving with 2x, the speed of faster train is, that means in the speed of 2x is what? Okay, now see, if person moves, supposed to be a person moves 1 meter in 1 second, that is 1 meter per second, and other person moves 2 meter in 1 second. Now can anyone tell if this person moves 1 meter in 1 second and this person moves 2 meter in 1 second? Now can anyone tell what is the velocity of approach, right? What is the distance covered by first one and the second one together? It is 1 plus 2, no? 3, isn't it? Likewise, in 2 seconds, if I ask, this will cover what is called as the 4 meter distance, and this will cover what is called as the 2 meter distance. So in 2 seconds, they will cover 4 plus 2, 6 meter distance. As in what? You have to add the velocities, isn't it? So over here, velocity is equal to, speed is equal to x plus 2x, that is 3x we have. What is the distance this train has to travel? 100 plus 100, 200 meter. And time they gave, time is equal to 8 seconds. Now I hope this is clear, right? See here, in 1 meter, in 1 second, this person will travel 1 meter. In 1 second, this person will travel 2 meters. So in all, how much they travel? 3 meter. That means 3 meter per second. You have to add the velocities, isn't it? Whenever two velocities are in the opposite direction, you have to add. So over here, velocity is 3x and distance we have 200 and time is 3. So velocity is equal to distance by time, that is speed is equal to distance by time. Speed is 3x is equal to distance is 200 divided by 8. So from this, x is equal to 200 divided by 8 into 3. So x we have, and that is you can write this as 8 2s are 4, 8 5s are 25 divided by 3 meter per seconds. So this is the speed of slower train. Speed of faster train, if you want, faster train, and that you can write, and that is 25 by 3 into 2, which is equal to 50 divided by 3 meter per seconds, or else 50 by 3 into 18 by 5. So this is 10za, this is 6za, you will get this is equal to 60 kilometer per hour. So the speed of faster train is 60 kilometer per hour, and if they want what is the speed of slower train, it is 30 kilometer per hour. So I hope this is clear. Chalo, next. Okay, so in this fourth question, it is given figure shows the displacement time graph of a particle moving in a straight line. Find the signs of velocity and acceleration of a particle at time t is equal to t1 and t is equal to t2. Okay, so at this point we want what is called as the acceleration and velocity, and at this point we want acceleration and velocity. So I'll just draw it separately and I'll show. So for the first one, graph is somewhat like this, and for the second one, graph is somewhat like this. Okay, now. So at this point we want, so this is t1 given, and at this point we want this is t2 given. Okay, no problem. Chalo. So see here. Now whenever this type of graph is given, consider any 2 points on the graph. I am considering this is the initial point and this is the final point. Why? Because it will be simple, right? Likewise over here I'll consider this is the initial point and this is the final point. Now some of you will say, why this is initial and why this is final? Because see, time, right, time will increase in this direction, right? So if you consider this as initial, then you can consider this as final, no? T is equal to, so that is why reading the graph is very important. 0 second, then 1 second, then 2 seconds and 3 seconds, and likewise. So if you consider this as 3 seconds as initial, then you have to consider 5 seconds as final, isn't it? Likewise, initial 1, final 2. Okay, now see, at 1, if you consider at 1, and if you draw the tangent, it is somewhat like this. So with respect to horizontal, if you see, with respect to horizontal, its velocity is 0 meter per seconds. Why? Because tangent of displacement time graph gives velocity. Okay, no problem. So at a second point, if you draw the tangent at 2, if you draw the tangent will be somewhat like this, and as you can see, this angle theta 1 supposed to be. Now this theta 1 is acute angle, isn't it? It's not obtuse. Acute angle means what? It is lesser than 90 degree. Whenever angle with respect to positive direction of x-axis is lesser than 90 degree, at that point velocity is positive. So over here the velocity, the final velocity we have at 2, this is velocity at 1, must be equal to what? Positive, right? So the acceleration you can write is positive quantity, that is v2, minus the 0 meter per seconds divided by the total time we have is t2 minus t1. So over here v2 divided by t2 minus t1 indicates this acceleration is positive. So I hope this is clear. This acceleration is what? Positive. That means from here till here, throughout its motion, its acceleration is positive. And what about the velocity? Velocity also increasing. No, see, at this point it is 0 meter per second. At this point, if you see, its angle is somewhat theta dash. At this point, if you see, its angle is theta 1. So theta 1 is greater than theta dash means velocity is increasing continuously. As the velocity is increasing continuously, acceleration has to be in the direction of the velocity. That means if acceleration is positive, velocity also positive. I hope this is clear, right? So at t1, both acceleration as well as velocity is positive. Okay, no problem. Now analyze this second graph. And I know most of you will have the confusion in this, right? So to analyze this, right, I'll tell the very simple method. Just follow it, and you will be clear with all the doubts whatever you have, right, in this question. So see, at 1 and at 2. So firstly draw the tangent at 1. Okay, this is the tangent at 1. With respect to horizontal, if you see, it is obtuse theta 2 supposed to be. And if you draw the tangent at 1 and at 2, with respect to horizontal, if you see, this v2 is 0 and v1 is negative. Why negative? Because the angle is obtuse. No, obtuse indicates greater than 90 degree. Whenever angle is greater than 90 degree, tan of greater than 90 degree is negative, and that is the reason velocity is negative. Okay, so what is the acceleration? Final velocity, that is 0 minus of negative v1 divided by the time is t2 minus t1. So as you can see over here, we have v1 divided by t2 minus t1. Though velocity is negative, acceleration is positive because this quantity is also positive. So acceleration in this case is positive, but the velocity is negative. Velocity is negative. So you can write at t1, that is at1 comma vt1 and at2 are positive and vt2 is negative. Chalo, so I hope all these quantities are clear to you all. Now if you have any doubt in reading the graphs, I'll recommend to watch that video whatever I provided for the graph, right? Fifth question. In this question it is given the velocity time graph of a particle moving in a straight line is shown in the figure. In the time interval from t is equal to 0 second to time t is equal to 14 seconds, find average velocity and average speed. Okay, so over here average velocity we want and average speed we want. So average velocity is nothing but what? Average velocity is equal to, you can write total displacement by the total time, and average speed you can write total distance by total time. Total distance by total time. So over here what is the total displacement in this case? Total displacement you can find by using this triangles area, rectangles area, triangles area, and again a triangles area. So I'm writing directly now. What is the triangles area? Half base into height. Base is 4, height is 20, so 20 into 2, 40. Plus, what is this rectangles area? 2 into 20, 40. Plus, here also half base into height, 6 to 10, 4, so it is 40 again. Minus half base into height, this is 2 and this is 10, so it will be 20 divided by we have the total time is 14 seconds. So whatever it is now, it is 120 100 divided by 14, which is 50 by 7 meter per second. Now to find total distance, wherever in displacement negative sign is there you have to put the positive sign, that's it. So it will be 40 plus 40 plus 40 plus 20 divided by total time is 14, which is equal to 140 divided by 14, which is equal to 10 meter per second. So this is the average speed we have and this is the average velocity we have. So it is that simple. You have to just find the total displacement, total distance divided by total time, you will get average velocity. If you find the total displacement, you will get the average speed if you find the total distance over here. Chalo, next. The graph describes an aeroplane's acceleration during its takeoff run. The aeroplane's velocity when it lifts off at t is equal to 20 seconds. Now we know that acceleration time graph, area under acceleration time graph gives area under acceleration time graph gives change in velocity. Right now, change in velocity. So do remember this. So change in velocity we have, and that is equal to area under acceleration time graph. So we have, this is the triangle, then a rectangle. So I'm writing directly now 1 by 2. This is 2 is the height and base is 10. This is the area of triangle, then a rectangle. Then we have what is called as 3 into 10 plus, then we have this big rectangle, this is 10 and this 5. So 5 into 10. So change in velocity we have, and that is change in velocity is equal to 10 plus 30 plus 50, which is equal to 80 and 90 meter per second. This is the change in velocity. They didn't mention the initial velocity. That indicates we have to consider the initial velocity as 0. So v minus u is 90 meter per second. So u is 0, indicates final velocity we have is 90 meter per second. So what is the velocity of aeroplane at its takeoff? It is 90 meter per second. So I hope this is clear. Now the next question. In this question it is given a lift starts from rest. Its acceleration is plotted against time. When it comes to rest, its height above its starting point is okay. So actually we want what is called as the height, right? So area under acceleration time graph gives the velocity, right? Velocity, and from that velocity we can find what is called as the displacement, right? From the acceleration also we can find the displacement. Chalo, let's find then. This is the acceleration, this is the time graph given. This is what is called as 2 meter per second squared. This is 4. Then this is minus 2 we have. And this is 8, this is 12. Now what is the displacement in the first case? It is half into acceleration is 2 into t squared is 16. So we have 16 meter. So in this 4 second, the lift will go to the height of 16 meter. Okay, at 4 second, what is the velocity? So v is equal to u plus 80. U is 0. A is 2 into t is 4, which is 8 meter per second. Now after this acceleration is 0, okay, it is moving from 4 seconds to 8 seconds with the acceleration 0, indicates velocity is constant. So in that, s is equal to v into t we can use. So 8 into 4, which is 32 meter. 32 meter. At this point, what is the velocity? velocity will not change. It will be 8 meter per second. Initial velocity is 8 meter per second. Now what is the displacement then? S is equal to ut plus half at square. 8 into 4. Why 4? Because 8 to 12 4 seconds. Minus 1 by 2. 2 into t square is 16. So this get cancelled. We have 32 minus 16, which is 16 meter. Which is 16 meter we have. So this is 16 meter. This is 32 meter. And this is again a 16 meter we have. So total displacement from its starting position we have is 16 plus 32 plus 16, which is equal to 64 meter. Okay now. So I hope this is clear. Initially its velocity is 0. That's why we can directly use S is equal to ut plus half at squared. U is 0, half at squared. Now after 4 seconds, what is the velocity? V is equal to u plus at. A is 2 and time is 4. So 8 meter per second. That velocity will be constant throughout. Why? Because from 4 to 8, acceleration is 0. Whenever acceleration is 0, body at rest, remain at rest. Body in motion, remain in motion. At 4 seconds, it is in motion. That's why it will be in motion. So V is equal to A into T. From that we found out the final velocity. That final velocity is the initial velocity till from 4 to 8. But that initial velocity is constant, right? So we have S is equal to V into T. V is 8, T is 4. So 8 into 4, 32 meter during that 4 seconds. Now after this we have deceleration. Now how to find deceleration displacement? It will be S is equal to ut plus half at square. U we know that is 8 meter per second. 8 into 4 minus 1 by 2, 2 into 4 squared. So 64 meter is the correct answer for this question. So that is the option B is the correct option. So next, when a ball is thrown up vertically with velocity v0, when this ball is thrown up with a velocity v0, it reaches a maximum height of h. Okay, no problem. It reaches maximum height of h means final velocity is 0. If one wishes to triple the maximum height, okay, so now with what velocity we have to throw so that now its height will be 3 times the initial height. Okay, so what is the maximum height formula? H is equal to v0 square divided by 2g, and this 3h must be equal to v dash square divided by 2g. So just take a ratio of this equation 1 and the equation 2. We'll see. It will be h by 3h is equal to v0 square divided by 2g, multiply it with 2g divided by v dash square. So this 2g get cancelled and we'll get v0 square divided by v dash square. This h get cancelled. V dash is equal to root 3 times v0. So you have to multiply initial velocity with root 3, then you will get the 3 times the maximum height that you want. Okay, so next question, 9th question now. A stone is released from a rising balloon accelerating upward. So this is the balloon which is given, and one stone is released from it. Whenever, do remember, whenever the contact between the accelerating body and the body which is just released, right? Do remember, very, very, very important. Whenever contact between the body which is accelerating upward and the body which is being released, right? Whenever contact between body which is accelerating upward, that is this balloon, and the body which is being released, okay, released is not there, only velocity is being retained by the body, but the acceleration or force will become immediately zero, right? Immediately zero. Once that contact is released, at that instant only the acceleration force will become zero. So on this body, once it is released, it will have the acceleration, and that is only due to the acceleration due to gravity. Only due to the acceleration due to gravity, and that too in the downward direction. Just after the release, what will happen? Immediately the acceleration of the balloon on that body will become zero immediately at that instant after the release, right? And we can say that only the acceleration due to gravity is acting on that body. So I hope this is clear. Now the next question and the last question in this, we have, in a car race, car A takes time t less than car B. Okay, so we have a car race supposed to be. It is a fair car race, indicates initial velocity of car A is 0 meter per second and the initial velocity of car B is 0 meter per second. Only difference is car A is moving with acceleration AA and car B is moving with acceleration AB. Time required for a car A, we will consider this is the finish line. Time required for a car A is TA and the time required for a car B is TB. Then we want the relation between V, A1, A2 and T. So, okay, what is V, what is T and A1, A2, we'll see. Assuming that, okay, both cars starts from rest and travel with a constant acceleration, A1, A2, so A, B, I2. And it is given car A takes time t less than car B. So time TA of car A is less than car B means TB minus T. Okay, and passes the finishing point with the speed V more than car B. Okay, so it is the final velocity of car A is VB plus V. Why? Because it is going more than the velocity of car B, isn't it? With by what? V. Okay, no problem. Now see here, VA is equal to what? VB plus V, and TB is equal to what? TA plus T. Now can we write VA as AA into TA, which is equal to AB into TB plus V? Now what is TB? TA plus T. Put in this equation. So we'll get AA TA is equal to AB TA plus T plus V. No problem. So we'll get AA TA is equal to AB TA plus AB T plus V. Now this TA one side, we'll get AA minus AB into TA is equal to AB into T plus V. Okay, so this is equation number 1, we'll say. Now displacement of car A and the displacement of car B are same. Why? Because from initial to final position displacement is same, no? So we can write displacement of car A is equal to the displacement of car B and the initial velocity is 0. So can we write 1 by 2 AA into TA squared must be equal to 1 by 2 AB into TB squared. So 1 by 2 A, so 1 by 2 get cancelled. So we can write AA TA squared must be equal to AB. What is TB over here? TA plus T whole square. So it will become a root. We'll take square like square root. It will become root A TA must be equal to root AB TA plus T. Okay. So from this we'll calculate the value of TA and we'll put it over here. It will become root AA minus root AB into TA is equal to root AB into T. Now what is the value of TA then? TA is equal to root AB divided by root AA minus root AB into T. This is equation number 2. Now from equation 1 and 2, from equation 1 and 2, we can write AA minus AB into what is TA? Root AB divided by root AA minus root AB into T is equal to AB into T plus V. Okay. Now what is AA minus AB? So we can write this as root AA whole squared minus root AB whole squared. So which is nothing but root AA minus root AB and root AA plus root AB, है ना? A squared minus B squared formula. So once we write that, we'll get root AA minus root AB times root AA plus root AB into root AB divided by root AA minus root AB into T, which is equal to ABT plus V. So this and this will get cancelled. Now we have root AA plus root AB into root AB into time T is equal to ABT plus V. Now multiply by root AB, so you will get root AA into AB plus AB times T is equal to ABT plus V, and as you can see over here, we'll get root AA into root AB into T plus AB into T is equal to AB into T plus V. So this get cancelled and we'll have V is equal to root of AA AB into T. So that is the answer which we have. So we have to prove that the velocity V is root of A1 A2 times T. So I hope this is clear to you all. Now if anyone has any doubt, they can always comment in the comment box. I'll try to reply to your comment as soon as possible. Thank you so much.